Okay, so this is our second part of our transformations unit. We've already talked about translations. That was the first transformation we talked about. Transformations were when we took a figure and we slid it in a straight line to different places on the graph. Okay. Today we're going to focus on reflections, which is probably our second easiest form of transformation behind translations. Reflections, I think, are pretty simple. We should get through this pretty quickly. If you're in your book, we are on page 339. You can follow along there. So let's check it out. All right. A reflection is a transformation that flips across a given line. Okay, we're just going to take it literally reflected across that line so that you get what's going to look like the opposite. Okay, whatever line that we flip over is going to be called the line of reflection. Most of the time, that's going to be either the y-axis or the x-axis. We use those more than anything else. We could use other lines to reflect over, but those are a little bit tougher. They don't come up as often, but we are going to do some examples of those as well. So, we're going to jump right in. We have triangle ABC here, and we're gonna do a couple of examples with it. We're gonna reflect it over the y-axis, over the x-axis, and then I'm gonna give us a different line of symmetry. So I'm gonna give us some work over here, or some room over here to work. Okay. All right. First thing we're gonna do, and we'll do it in a different color. We'll do this in purple. We're gonna flip over the y-axis. Okay, so here's our y-axis. It's up and down. It's going to be labeled as y, so that should make things easy. All right, we want to see how far away every point is from that y-axis, since that's our point of reflection. So I can see here that A is 2 units away from that line of reflection. So we're going to go 2 units the other way. C was also 2, so we're going to go 2 this way. B was 6 units, so we're going to go 6 units this way. That gives us that triangle right there. We can see that it's just been flipped over, all right? Literally, a reflection, you think of a reflection in the mirror. If you're wearing a name tag in the mirror and you look in the mirror, your name is backwards, right? Because of the reflection flips everything. It's the same thing here, okay? We've reflected this shape. The shape looks exactly the same, it's just backwards. Okay, so if we were to flip over the x-axis, we'll do that in red. If we flip over the x-axis, instead of going up 2 for C, we'll go down 2 for C. Instead of up 2 for B, we'll go down 2 for B. And instead of up 5 for A, we'll go down 5 for A. Now, I'm still putting all of these primes to figure out which came first, which came second. Now, I already have an A prime up here. So what I'm going to do is I'm going to make all of my red, I'm going to do double prime. So that way I can talk about different triangles and know which one I'm referring to. Okay, so these are our most basic reflections, x-axis and y-axis. Okay, let's talk about if they were to do something a little bit more tricky. Let's say, and I'll do this in red. Now this is going to start in blue. This is going to start to kind of overlap a little bit, but it should be okay. Just try to figure out what I'm doing here. They could label a different line of reflection. Instead of saying x-axis or y-axis, they could say your line of reflection is going to be y equals 1. Okay? So if y equals 1, if we were to graph the line y equals 1, that's a horizontal line through the y-axis where y is 1. Okay, we've learned how to do these graphs back when we were doing linear equations. Remember, if it's x equals something, that's a vertical line. Y equals something, that's a horizontal line. So now, if that's my line of reflection, I do the same thing over that line. I'm going to treat that like it's my x-axis. So instead of up 1, I'll go down 1. There's my new C. Instead of up 1, I'll go down 1. That's my new B. Instead of up 1, 2, 3, 4, I'll go down 1, 2, 3, 4. And there's my new A. Connect those. And now I've reflected over y equals 1 instead of reflecting over the x-axis. That's every example of every kind of problem you could see with reflection. They're really not that bad. Okay, now what I do want to talk about, and we'll just look at these top two for now to figure this stuff out. When we had a translation, how did our image and pre-image compare? When we had a translation. Same size, same shape, which is also known as congruent. Okay, so our pre-image and our image, our original and our new figure in translations were congruent. What about in reflections? It's still the same size. It's still the same shape. It's just backwards, right? Okay, so these are still congruent. The pre-image and the image are still congruent to each other. If we were to look at it, line AC is still congruent to line A prime, C prime. Just because they're backwards, that doesn't change. So we still have the same size, same shape. The only thing that has changed, and this was a word that we talked about during translations, was the orientation. Okay, our orientation is a little different. Okay, it's the opposite horizontally, or it's upside down if we reflect over the x-axis. Okay, so just like in translations, our pre-image and image are going to be the same exact shape. All right, I think that's everything I want to talk about on this page. Yeah. Okay, we'll do the same thing with this. All right, let's go over the y-axis and the x-axis. We'll just go with the axis for now. You get to where this is very quick and easy. I can look, if I'm doing y-axis, left 2, I'll go right 2. Left 2, I'll go right 2. Okay, we can still do the same trick we did with translations where I can see, all right, I went up 1 and over 2 to get t. So I'll go up 1 and over 2 here to get this t. I just had to go right instead of left. For p, it's down 2 over 2. And there's my new trapezoid. Same shape, same size, just reflected. I can do the same thing going over the y or the x-axis. Okay, now for this example, let's talk about something they do. Now that we know multiple transformations, they're going to start giving you different steps. Rather than just say reflect over the y-axis, they'll say reflect trapezoid TRAP over the y-axis and then over the x-axis. So they're going to give us 2 different steps. Now we just did the first step. We reflected over the y-axis. Now we need to reflect it over the x-axis. Okay? This is why I told y'all we need to be able to label each point because it makes it easier to do this next step. So now I'm going to reflect this over the x-axis. It's going to be our new, the image just became the pre-image. So now instead of up 1, we'll go down 1. This will be P double prime. Instead of up 6, I'll go down 6, which will be down here. Instead of up 3, down 3. Instead of up 5, we'll go down 5, which would be there. Okay. Have not been saved. Cancel. There we go. All right. Connect those lines. And now we have the result of 2 reflections back to back. Now by putting the double primes, I can immediately spot which one was the result, which one was the original, which one came in the middle. Okay, so that's a great habit to get into, and I'll start counting them wrong if you don't do that. Okay. You might want to make note of page 341. Okay. I know this video should give you some examples of how to do these, but page 341 has a written example that really defines how reflections are done. You can see that they took their pre-image of XYZ and they're reflecting over which axis? The x-axis, and we can see them actually drawing it out. Okay, they said instead of down 3, we'll go up 3. Instead of down 1, we'll go up 1. Instead of down 5, we'll go up 5, so on. Okay, so they're literally drawing it out for you so that you can see how they got x, y, z prime. So this is a great page to just have book-geared or whatever, so that whenever, sometimes I'll let you use your book to help you with homework. This page gives you a straight-up example, even though I really don't think reflections are that tough. Okay, we'll do 2 more examples of graphing, and then I want to talk about the algebra, which is a little bit tougher. Okay, so right here we're going to go over the y-axis. So instead of left 2, right 2. Instead of left 3, right 3. Instead of left 5, right 5. Okay, and we can go, do that for each point. There we go. Okay, now I did want to talk about this example because it can throw some people off. We're going to reflect this one over the y-axis. Now, people get confused because the shape is actually crossing the y-axis. So this is where direction comes into play. All right. We'll go in order of points. So we'll start with point A. The line of symmetry is the y-axis. How do you get from the y-axis to point A? 3 to the left. So if we're going to do the opposite of that, we're going to go 3 to the right. Good. So now with point B, we went right once. So how am I going to reflect it? Left once. Good. All right, we could do that with each of these. This will become D prime, and this will become C prime. And there we go. All right, a little harder to see because they are overlapping, but you follow the same rules even if it's crossing the y-axis. Don't let that confuse you. All right, so that's a good example of like a physical reflection. So what I want to do now, and I'm going to zoom in up here, and I'm just going to make my own little section to do notes in. We're going to talk about the algebraic rules. Now, we did this with translations. Remember when we added numbers to x, that meant we moved right that many times. When we subtracted from x, we moved left that many times. When we added to y, we moved up. When we subtracted from y, we moved down. Okay, that was our algebra rules for translations. Now, there are algebra rules for reflection, but they have some limitations, and there's some things that can be confusing about them. Okay, if you're watching the video, you're not going to really be able to see me act some of this out, so hopefully you remember it from class. But with translation, okay, it was pretty easy to remember because the x-axis kind of gives us a guide that x goes left, x goes right, and y is up and down. Okay, when we do reflection, that's why it's going to start messing with your head a little bit because it's going to kind of go opposite of what you think. We can only use the algebraic rules if we're reflecting over the x-axis or if we're reflecting over the y-axis. We have to be using these as a line of symmetry, or not a line of symmetry, a line of reflection. So if the problem itself is saying reflect these over y equals 1, you're going to actually have to draw that out. But when it comes to doing an algebraic rule, if they give us that the line of reflection is the x-axis to the y-axis, this becomes a little bit easier. We'll start with the x-axis. Now, if we're reflecting over the x-axis, the first thing you're probably thinking is that x goes in what directions? Yeah, x goes left and right. Okay? However, if we're reflecting something over the x-axis, let's take this heart, and I reflect it over the x-axis, is it going to move to the left or is it going to move down?
It's going to move down.
It's going to move down. Okay, try to draw an upside down heart. Not going to be pretty. That's not bad. All right, so by reflecting over the x-axis, did my shape move left and right or up and down? Up and down. So when I reflected over the x-axis, there was actually up and down movement, right? Okay, so if you looked, a lot of times this is what I'll do in class, and you won't be able to see this in the video, but if you're in the classroom, you can see this. I'll say if we're reflecting over the x-axis, my hand right now is moving up and down, right? So which coordinate deals with up and down movement? Y. So when we reflect over the x-axis, our y is actually going to be the coordinate that changes. Our x is going to stay the same. So the way that would come out algebraically, we would say, okay, you start with your x and y. Okay? Since we're moving up and down, the x isn't going to change at all. The x is going to stay the same. Okay? But since it's a reflection, our y is going to have its sign flipped. Okay? So we do the opposite sign for y. And that's it. Okay? So if we had, let's say, 4 and 3. If I were to reflect that point over the x-axis, that would become 4, negative 3. If I had 4, negative 4, that would become 4, positive 4. Okay? So this can be confusing because when we reflect over the x-axis, the y flips its sign. It's kind of opposite. It always works opposite. So with that in mind, if I reflect over the y-axis, what do you think is going to happen here? The x is going to flip its sign. Good. Now we don't want to get in the habit of saying x is negative because x might start out as a negative, right? This might be our original point. That might be our pre-image. If we reflect that over the y-axis, we're not so much making the sign negative, we're flipping the sign. So instead of a negative 3, now it'll be a positive 3. Okay. If I had 5, 1, this becomes negative 5 and 1. There we go. So a little bit tougher. Again, you'll see me do this a lot. We're flipping over the y-axis. I'll use my hand and I'll show you. My hand right now is moving left and right. Left and right means that my x has to change. Reflection means we're going to flip a sign. Okay, so that's the algebraic rules for reflection. All right. Okay. So, and then just to kind of review, because I see a question that they're asking here, our size and our shape does not change. Okay, what's the one, besides position, what was the one thing that changed? Starts with an O.
Orientation.
Orientation, there it is. The orientation will change. The position will change, but the size and the shape will not. Okay, so it should be easy to find congruent sides. Okay, if you have triangle ABC, AB is always congruent to A prime, B prime, and so on and so forth. So that is our quick run through of reflection. Okay, we're gonna do some practicing on this and some more practice on translation to really make sure we got these things locked down. But that is our video.